Hello, my name is Jim Walters. I'm a test engineer with Keysight Technology, and today I'm going to be showing you our new IntegraVision PA2003A power analyzer. And what's nice about this power analyzer, it's set up to measure three-phase power, and today we're going to show you a video of three-phase motor, and I will show you a phasor diagram of the three-phase motor and then show you the key pieces of information that you can grab from the phasor diagram. So here we go. I'll turn on the motor. The first thing I'm going to do is auto scale. That's a nice feature that'll get all the signals in range. It looks like they're pretty much in range right now, but we'll do the auto scale. Okay, so now I have auto scale on the first three channels. Now, the way that a three-phase motor works is you have voltage and current on each one of the three legs of the phase. So for me to do that, I'm going to set up a wiring mode that shows you the three-phase, and this is the three-phase delta configuration. So we've lumped all the signals on line 1, line 2, and line 3 into this grouping, which we call Group A. So when I do my analysis, both from the phasors and the analysis menu, I'll be calling on Group A. So the first thing I'm going to do, close the wiring diagram down, and I'm going to bring up our analysis panel. Now this analysis panel is set up to look at Group A, which I've set up in the wiring diagram, and this gives you a bunch of parameters about the voltage, the current, and the power that's being produced right now. So you can see that we're producing 56 watts of power driving the AC motor. Now I'm going to go to the phasor diagram, which is this button here. Now this shows the phasor diagram. Each one of the three legs that we're interested in is color-coded differently, and we use V1 as our reference point. So right now you can see the yellow is V1, and I'm going to make V1 a little bit bigger by adjusting this scale. Go down a little bit. Whoops. Okay, so you can see, you can read off of here V1, each one of these little circles is a different increment, and if you look at the value over here, it says 34 volts VRMS for both V1, V2, and V3. Now, as you turn up the speed of the motor and make it go faster, it consumes more power, and what you see on the phasor diagram is the voltage value will get bigger. So I'm turning up the motor now, and the motor, the voltage on each one of the legs now has went from 30-something volts up to 46 volts. Turn the motor back down a little bit, and you can see the voltage gets smaller as you lower the voltage. Now, one of the key parameters on this phasor diagram is the fundamental frequency. So this tells you how fast the motor is spinning. Right now it's spinning at 40 hertz. If I increase it a little bit, you can see now it went up to 44 hertz and go really fast, and now we're running 55 hertz. The other pieces of information on this screen give you information about the VL1 to VL2. Notice that all of these angles here are around 120 degrees minus, which you can see in between V1 and V2. So that gives you the angle. Then we also have each individual line and a sum average for the voltage. Right now we're around 29 volts VRMS. And then over here is our displacement power factor. Now this gives you quick insight to all three legs. If you wanted to see an individual leg, we can go back and change the phasor diagram and change the analysis panel to just look at one leg at a time. So I'm going to look at this channel 1 leg, which is our V1, and now you see that all of this information now is related to channel 1. Now the phasor diagram is still showing the Group A, so I'm going to bring up a new phasor diagram that just looks at channel 1. And so now you're just looking at one of the three legs, and this shows the V1 to I1 relationship, and this shows all the parameters related to V1. And the same thing that I did before is you increase the speed, you can see the voltage getting bigger, and you can see the VRMS getting larger and the frequency getting better. So this technique allows you to quickly look at a group channel, three-phase measurements. We'll go back to that. And to bring up a phasor with the three-phase group information. So this is very useful if any of your legs are unbalanced, your motor will not be operating correctly. So this phasor diagram in conjunction with our power analyzer allows you to quickly look at your motor and make some sound decisions about whether it's working correctly or not. So that concludes this video. What I've showed you today is that our new 3-phase power analyzer can look at 3-phase motors and provide you with a phasor diagram that gives you a lot of information about the system. So thank you very much for watching this video. We'll see you. Thank you.